In this question, we're asked to look at this sequence and determine whether it's monotonic, bounded, and if it has a limit. So monotonic, remember, means that it's either always increasing or always decreasing. So we're going to look at this as a function, 3 to the x plus 1 plus 7 over 3 to the x. We're going to do some algebra to simplify it. We're going to write that as 3 to the x plus 1 over 3 to the x plus 7 over 3 to the x. This simplifies. This is like 11 3's over 10 3's. I have an extra 3 in the numerator, so that just simplifies to a 3. And then this is still plus 7 over 3 to the x. If I want to talk about increasing or decreasing, I need to think about its derivative. F prime at x will be, the 3 goes away. So let me write that one other way. This is 3 plus 7, 3 to the negative x. Just so it'll be a little easier to take the derivative. The 3 goes away. The 7 as a constant goes along. Derivative of e to the x is e to the x, but the derivative of 3 to the x is 3 to the x times ln of 3. Remember, I get an extra ln of 3 when I'm taking the derivative of this, but I also get a negative from the chain rule, from the exponents that's there. So let's just make that a little nicer. 7 times ln of 3 times 3 to the negative x. Now what? Well, x is always positive here, and actually it doesn't matter. 3 to the negative x is always positive no matter what. This is positive, ln of 3 is positive, negative 7 is negative. This is always negative. Which means that this series, this sequence, is monotonic but going down. Yes, monotonic. Decreasing. Is it bounded? And does it have a limit? Let's look at the limit question first. Remember, when asking about the limit, I'm going to treat this just like the algebra that we did as a function. So this is going to be 3 plus 7 over 3 to the n. What is the limit as n goes to infinity? Well, as n goes to infinity, this denominator goes to infinity. And so 7 over infinity is 0, so that limit is just going to be 3. Since it's decreasing always, and the limit is 3, that means that the picture must be something like this. Decreasing down towards 3, and so it is bounded. Right, it's bounded below by 3. It's also bounded above, but really just because there's a first term. And whatever the first term is, that's the highest value that it will be, and then it decreases afterwards.